Hello, Java enthusiasts. Welcome to episode 3 of our Java 21 series. I'm Suma, and today we're going to explore some exciting new features that will make your Java code easier to write and understand. Even if you're new to Java, don't worry. We'll break everything down so you can follow along easily. Have you ever wished you could write less code to do more? Or maybe you've struggled with complex if-else statements? Well, Java 21 has some idea that you can use when needed that will make your coding life much easier. Let's dive in and see what's new. First, let's talk about pattern matching for switch expressions. This is a powerful new feature that makes our switch statements much more flexible. In older versions of Java, switch statements could only match simple values like numbers or strings. But now we can do much more. Let's look at an example from previous version. We'll create a Java class named oldShapeCalculator. Its purpose is to calculate areas of various geometric shapes, circles, rectangles, based on the shape type and its parameters. Let's define a method called calculateArea. This method takes two parameters: a string representing the shape type, a variable length argument, varargs, of double values representing the shape's parameters. Here, variable length argument of double syntax indicates that the method can accept any number of double values as parameters. Inside the method, we initialize a double variable named area to 0. Next, we'll implement a switch statement that evaluates the shape type parameter converted to lowercase. For the circle case, we first validate the number of parameters. Circle needs only one parameter as an argument. This if statement checks if the number of parameters is not equal to 1. It throws an illegal argument exception with a message indicating that a circle requires exactly one parameter. If the parameter count is correct, we calculate the circle's area. This line computes the area using the formula, where parameters represents the radius. Finally, we use a break statement to exit the switch block. Next, we'll implement analogous logic for the rectangle case. In this scenario, we require two parameters for accurate area calculation. We'll initiate a conditional check to verify if the parameter's array length is exactly 2. This validation ensures we have the correct number of inputs for our rectangle calculations. Assuming the parameter count is correct, we'll compute the rectangle's area using the standard formula. Here, parameters represents the width and height of the rectangle. To conclude this case block and prevent fall through to subsequent cases, we'll insert a break statement. Next, we will address the default case. If the shape type does not match any of the predefined cases, we will throw an illegal argument exception indicating that the shape type is unknown. Following this, we will implement our main method to test the calculateArea function and output the results to the console. Finally, we'll summarize the entire code structure to reinforce our understanding of how each component interacts within the oldShapeCalculator class. This version maintains technical accuracy while ensuring clarity and conciseness. Let's summarize the code. This Java code defines a class called oldShapeCalculator that contains a method called calculateArea. The purpose of this method is to calculate the area of a shape based on the shape type and its parameters. The shape types supported by this method are circle, rectangle. The method calculateArea takes two parameters: a string shape type that represents the type of shape, and a variable length array of doubles parameters that represents the parameters for the shape. The method first initializes the area to 0, then uses a switch statement to calculate the area based on the shape type. For each shape type, the method checks if the number of parameters is correct, throws an exception if the number of parameters is incorrect, and calculates the area using the appropriate formula. The results are then returned as a double. The main method demonstrates how to use the calculateArea method by calculating the areas of a circle, rectangle with different parameters. The results are then printed to the console. To use this code, simply copy and paste it into a Java environment and run the main method. This will display the areas of the shapes to the console. The same code using pattern matching for switch expressions in Java 21 looks like as shown in figure. Let's deep dive into it. Method signature. The method now accepts an object instead of a string and parameters. This allows us to directly work with shape objects. Switch expression. The switch expression evaluates the shape object. Each case checks if the object is an instance of a specific shape type, example, circle, rectangle. Pattern matching. For each shape type, we use pattern matching to bind the object to a variable, circle, rectangle. This allows direct access to the object's fields without casting. Yield statement. The yield keyword is used to return a value from the switch expression. Default case. The default case throws an exception if the shape type is unknown. Let's summarize once again. This Java code defines a class oldShapeCalculator with two records, circle and rectangle. The circle record has a radius field, while the rectangle record has width and height fields. The calculateArea method takes an object as input and returns the area of the given shape. It uses a switch statement to handle different shape types. If the shape is a circle, it calculates the area using the corresponding formula and yields the result. If the shape is a rectangle, it calculates the area using the formula and yields the result. If the shape is not recognized, it throws an illegal argument exception. In the main method, two shapes are created, a circle with a radius of 5 and a rectangle with a width of 4 and a height of 6. The calculateArea method is called for each shape. And there you have it. We've explored pattern matching for switch pattern and some neat ways to simplify our code. These features might seem small, but they can make a big difference in how we write Java code. Before we go, here's a challenge for you. Try taking some of your old Java code and see if you can simplify it using these new features. You might be surprised at how much cleaner your code becomes. We will discuss the record pattern in next episode. If you found this helpful, don't forget to like and subscribe. If you have any questions or want to share your own Java 21 discoveries, leave a comment below. In our next episode, we'll be diving into some more advanced features, so stay tuned.